For the last decade or so, some of the most powerful artificial intelligence in the world has lived inside a cage, a digital one. But what happens when it finally gets a body? That's what we're digging into today, the incredible moment when code becomes a robot.
This quote really just hits the nail on the head. I mean, think about it. The most advanced AIs we know in use, things like ChatGPT or DALL-E, they've been these brilliant minds totally trapped behind a screen. Sure, they can write a sonnet or paint a masterpiece, but they can only ever move pixels and text around. They live their whole existence in the digital realm, inside these massive humming data centers.
But what if we could unlock that cage? What if that incredible intelligence could actually interact with the physical world, just like you and I do? What if it could see through cameras, move with motors, and actually pick things up with mechanical hands? Well, that's the question that's driving the next great leap in technology.
And that leap has a name: physical AI. This isn't just some small upgrade, you guys. This is the moment that digital intelligence gets a physical body. It's being transformed from a disembodied brain floating in the cloud into a real, actual actor in our world.
So what is it exactly? At its heart, physical AI, and you'll sometimes hear it called embodied intelligence, it's all about creating systems that can finally bridge that gap between the digital and the physical. These aren't just computer programs anymore. They are machines that can sense the world around them, understand it, and then physically act on that understanding. To make this whole thing happen, a physical AI needs 5 key ingredients. First, obviously, it needs a physical body. That could be a humanoid robot, a drone, you name it. Second, it needs sensory perception. These are its eyes and ears, using tools like cameras and LiDAR, which is kind of like radar, but it uses lasers to build this super detailed 3D map of the world. Third, it needs actuation. That's just a fancy word for being able to move and interact using motors and hands. Fourth is a big one: spatial reasoning. It has to get a real grip on physics and geometry. And last but not least, autonomy. The ability to make its own decisions, to navigate a room, to manipulate an object, especially when things go wrong. You see, for the longest time, AI and robotics were like 2 separate worlds developing on parallel tracks. On one side, you had digital AI, the brain, getting unbelievably smart, but, trapped. And on the other, you had robotics, the body, with machines that could move and sense, but had pretty limited intelligence. Think of a factory arm just repeating the same exact weld for 20 years straight. Physical AI is where these 2 worlds finally, powerfully converge. So you might be asking yourself, why is this massive convergence happening right now? It's a great question, and it's not a coincidence. It's actually the result of 3 huge technological revolutions all hitting at the exact same time, creating this perfect storm for physical AI to finally break out. And those 3 catalysts are the explosion of foundation models, the insane power of GPU-accelerated simulation, and the rapidly falling cost of advanced hardware. Now, each one of these is a game changer all on its own, but when you put them all together, they create this incredible feedback loop that is just accelerating everything. First up, foundation models. This is a huge, huge piece of the puzzle. Large language models like GPT-4 basically give robots a brain that can understand us using natural language. You can just say, hey, pick up the red cup from the table, and the AI can figure out what a cup is, what red looks like, and then generate the whole sequence of motor commands to actually get the job done. Second, we've got simulation. See, training a physical robot in the real world is slow, it's expensive, and honestly, you're probably going to break it a few times. But now, with these incredibly powerful physics engines like NVIDIA's Isaac Sim, you can train thousands of virtual robots in a simulated world all at the same time. A training process that would take months of trial and error in the real world can now be crunched down into just a few hours. It's a massive accelerator.
And the third revolution might be the most important tipping point of all: affordable hardware. For decades, advanced robots were these multi-million-dollar research projects locked away in university labs. But that world is changing, and it's changing fast.
Okay, get this. In 2024, right now, you can buy a sophisticated, general-purpose humanoid robot, the Unitree G1, for just $16,000. I mean, that's less than the price of many new cars. This isn't just a small price drop. This is the democratization of robotics. This chart really puts that shift into perspective. Just a few years ago, a platform like Boston Dynamics Spot cost a cool $75,000, firmly in the territory of big corporate R&D budgets. Today, a full humanoid is just a fraction of that cost. This isn't just about making robots cheaper. It's about putting them into the hands of thousands of new developers, startups, and researchers. It's about to cause an explosion of innovation.
And look, this isn't just theory or stuff happening in a lab. Because of these three revolutions, physical AI is already being deployed. It's already out in the wild, transforming major industries. This is happening today.
In manufacturing, for example, Amazon's warehouses are a perfect showcase. You've got these Proteus robots zipping around, autonomously navigating incredibly complex environments to move products. And of course, there's Tesla's Optimus, which is being designed from the ground up to handle repetitive tasks on the assembly line.
Or what about healthcare? Robots like Moxie are already at work in hospitals. They're handling the logistics, delivering supplies, running lab samples, and moving medications around, which frees up nurses and technicians to spend more of their time on what truly matters: direct patient care.
The impact is even stretching into agriculture. At these really innovative farms like Iron Ox, a robot named Grover is responsible for transplanting seedlings, monitoring the health of thousands of individual plants, and harvesting crops with a kind of precision that humans just can't match.
And this is probably the most familiar example of all: autonomous mobility. Yep, self-driving cars from companies like Waymo and Cruise, they are absolutely physical AI systems. They use a whole suite of sensors to see the world, incredibly sophisticated AI to make split-second decisions, and actuators to navigate the ridiculously complex and dynamic world of our city streets.
Now, it all sounds amazing, but it's not all smooth sailing. There's a huge challenge that everyone in this field is working around the clock to solve. It's the one thing that separates a perfect simulation from our messy, chaotic reality.
It's called the sim-to-real gap. An AI model can learn to do a task perfectly inside a clean, predictable simulation where the physics are exact and the sensors never have glitches. But the real world? It's chaotic. Light reflects in weird ways. Surfaces have different amounts of friction. Motors don't respond instantly. Bridging this gap is pretty much the final frontier. The solution to this is actually pretty genius. It's a technique called domain randomization. See, instead of training the robot in just one perfect simulation, engineers trained it in thousands of slightly different ones, with varied lighting, different textures, slightly wonky physics. This forces the AI to stop just memorizing a perfect world and instead learn a flexible, robust strategy that can actually handle all the unpredictability it's going to encounter for real.
So, when you step back and look at the big picture, what we're really witnessing is a fundamental paradigm shift. Physical AI is the discipline that turns our digital creations into physical realities. Code literally becomes motion. Algorithms become action. And those virtual worlds that we build in simulation, they're becoming the blueprint for our physical world.
For a decade, we have watched AI learn how to think, how to reason, how to create, all inside a computer. Now, it is learning how to act in our world. And that brings us to the ultimate question that we are all now facing. What happens next?